right, so, I got a lot of kids, and you can't just say, hey, give me that churro, and I said, you guys got to split it. And you guys know little kids, you're saying like, hey, that's not fair. Yours is bigger than mine. I want that one. They start fighting and bickering, and you throw back. You probably did it too, right? So this brings us up to an idea called what is an equation. It's a statement when two expressions are equal. So if I break the churro in half, those are my two churros. They have to be equal or my kids are going to fight. If I give one kid a Slurpee, then the other kid gets what? Would it be equal if I said, okay, you get a Slurpee, but you're a little bit smaller, so you get half? Are they going to be happy about that? No, Autumn is going to go crazy. These are not equal. Does this make sense? Okay, so example, which of the following are equations? Well, equations have the symbol equal sign. So let's look for those that have equals. It's those, they're already circled. They're saying that the two sides, the left and the right side, are equal. These two, they're saying that these are equal. This is not an equation. Those in red, these are called expressions. Expressions have no what? No equal sign. All right, let's talk about properties of equality. Raise your hand if you remember doing these back in Math 2 with two-column proofs. Okay, you're not writing anything, you're just listening. Okay, so what does that mean? For example, addition property of equality says this. I should do -4 equals 8. Now, a student didn't know how to solve equations, so the student was actually guessing numbers. They were trying to put numbers into x. And to solve for x, what would you do? How would you move the -4 across the river? What would you do? You would do the opposite. Everyone say opposite. To move across the green river here, you're going to have to go the opposite. So if we're trying to move this to this side, I'm going to have to do the opposite. That is called the addition property of equality. I'll show you guys one more, and then in your notes, you're going to make up 2 examples for the other ones. Let's try division property of equality. So if I have the answer 3x equals 8, and x, for some reason, just likes to be by itself. So how can we make x happy? You would have to do what? Well, you're doing the opposite, because what do you see here? You seeing multiply, and the inverse or opposite of multiplication is? Division. So we would divide by 3. This is called the division property of equality. I have some bad news for you. I gave second period extra credit, but I didn't give this class extra credit. Why are you giving me that face? Are you guys happy?
No.
Is that fair?
No.
Is that equal?
No.
Just kidding, I didn't give them extra credit. But now you know, whatever you do to one side, you do to the other. If I do it to one period, I need to be consistent. Subtraction? Sure. Tell me your example. X minus 5 equals 10. Class, how would I get x by itself? So in this example, we would do what? Add. If I'm adding, this would be called what? Addition property of equality. So Devin, how can you change the problem so we get subtraction property of equality? X plus 5. Therefore, I can subtract 5 and you'll get x equals 5. Thank you, Devin. How about Ashley? You're going to do multiplication property of equality. Can you tell me what your example is? But if I put x over 2 equals, say, 22, class, what would I have to do to get rid of that 2? You would multiply 2 on both sides. This would give us the multiplication property of equality, because in green there, I'm multiplying both sides by 2. Okay?
We love math A, we love math A, we love math A. Every time we divide, we already know the path A. then we multiply. All we gotta do is roll the die. Ayy.